In a surprising turn of events, Kawasaki, widely known for its iconic green motorcycles, has taken a bold step beyond two wheels. The Japanese manufacturer recently introduced a new concept vehicle called Corleo, a machine designed not only to traverse all terrains, but also to redefine the very idea of mobility.
Imagine a horse that never eats, never sleeps, and never slows down. Now power it with hydrogen, swap out muscle for metal, and you've got Corleo Kawasaki's mind-bending new robot that walks on 4 legs and runs on clean fuel. Designed to conquer the kind of terrain that leaves wheels helpless. This machine isn't just futuristic, it could change how we travel entirely. What exactly is it made of, and how does it work? Join us as we explore the hydrogen-powered robot horse that's turning heads around the world. If you're enjoying this, subscribe. Supporting the channel is free and makes me so happy. Corleo, Kawasaki's robot horse. They say innovation is just reinvention, but every once in a while something shows up that flips the script entirely. In April 2025, everyone at the Osaka Kansai Expo leaned in, waiting for the familiar snarl of Kawasaki's next superbike. Instead, Kawasaki Heavy Industries rolled out Corleo, a hydrogen-powered 4-legged machine you can saddle and ride. Standing roughly 1.5 meters tall, about chest height for most people, and capped with a sleek sport bike visor, it looks like something that just stepped off a sci-fi storyboard. Inside its sculpted torso purrs a 150 cm3 hydrogen engine. Rather than spinning wheels, it drives a generator that feeds electric motors in each leg. Early specs peg output at roughly 20 horsepower, plenty for confident hill climbs without emissions. Each limb gets its own drive unit, so torque hits the ground instantly, and the only thing Corleo exhales is water. Zero tailpipe pollution, even in a rainforest. Those legs are the real magic. A motorcycle-style swing arm in each rear limb lets it rise and fall independently, soaking up shocks like an off-road bike suspension. Slip-resistant rubber hooves split left to right, spreading on sand and clamping on jagged rock, while AI vision sensors tweak every step, so Corleo moves with the calm certainty of a mountain goat, not the clatter of a machine. Climbing aboard feels familiar. A motorcycle-style saddle, simple handlebars, and fold-away auto-adjusting footrests. No joystick jungle, lean or nudge. The bars, and Corleo obeys like a living horse. Pressure sensors in the stirrups and grips read those weight shifts, turning your balance into steering commands. A compact dash tracks fuel balance and rider posture, displaying a hydrogen-level ring, a center-of-gravity dot, and a single-root arrow, nothing more. Corleo projects gentle, breadcrumb-style lights on the path ahead, onto the ground after dark, while a subtle underbelly light makes the whole machine look like it's hovering an inch above the trail. The frame blends carbon fiber weave with lightweight alloys and wears Kawasaki's signature electric green accents, keeping overall mass to about 180 kilo. Hefty enough for stability, yet light enough for nimble footing. Power comes from a rear-mounted hydrogen pack, a pair of quick-swap canisters whose behind-the-seat placement centers mass and keeps fuel safely away from the rider's knees. A race bike trick, repurposed for a robot horse. This ties Corleo to Kawasaki's broader ALEC mobility family, a future lineup of hydrogen concepts spanning legged vehicles to ships. Prototype numbers suggest Corleo can haul about 100 kilos, travel roughly 150 miles on a tank, and move at a jogging pace, perfect for rescue teams or anyone whose commute resembles an obstacle course. Kawasaki's concept video even touts a theoretical top speed approaching 100 km/h. The Expo prototype, meanwhile, kept to a careful walking pace, yet still climbed a cinder block pile without spilling the rider's coffee. For now, Corleo remains a concept, but it proves a radical idea. When wheels quit, legs and zero-emission hydrogen can keep humanity moving. We have met the horse. Now meet the heart that keeps it going. Corleo's hydrogen heartbeat. Think of hydrogen as rocket fuel served in a reusable thermos. Corleo carries that thermos behind the saddle, a tough carbon-wrapped cylinder full of compressed hydrogen gas. Pop 2 spring pins, slide the empty out, slide a fresh one in, click. The swap takes about as long as fastening a bike helmet, which means rescuers or park rangers never have to hunt for a wall socket. Once the new canister locks home, the 150 cubic cm single-cylinder engine wakes, up with a muted whir. Kawasaki tuned this palm-sized motor to burn nothing but hydrogen. Instead of driving the legs directly, it spins a generator that feeds batteries and 4 thigh-mounted electric motors. The chemistry is gloriously no drama. Hydrogen plus oxygen equals electricity and a puff of water vapor. No carbon dioxide. No petrol smell. Just steam. Why bother with hydrogen at all? Wait and wait. A tank that holds energy for hours weighs far less than the lithium battery pack you would need for the same range. So Corleo stays nimble instead of lumbering like a metal rhino. And because gas flows quicker than electrons, refilling takes seconds, not lunch breaks. That combo, light on the trail, quick in the pits, lets a single robot tackle a dawn to dusk shift without ruining the schedule. Of course, hydrogen has to get to the trailhead first, and Kawasaki has been laying the tracks. In 2022, the company's Suiso Frontier became the world's first ship to haul liquefied hydrogen across an ocean, carting the super-chilled cargo from Australia to Kobe, and proving that bulk deliveries are possible and safe. Picture a gigantic thermos bottle, 253 degrees below zero inside, rolling into port with enough clean energy to feed an army of Corleos. Critics rightly ask where that hydrogen comes from. Early batches were made from coal or natural gas. But Japan's energy planners, and Kawasaki with them, have pivoted toward renewable electrolysis. Pilot plants powered by offshore wind and mountain hydro are already trickling out green hydrogen, and every step down that road shrinks Corleo's lifetime footprint until even its fuel miles are carbon-free. Think of hydrogen as the 21st century. Hay bale. Only instead of feeding a living horse, it powers a mechanical mount that never tires, never sweats, and leaves the air as spotless as it found it. Revolutionary tech rarely appears overnight. Let's rewind the tape on Kawasaki's robot pedigree. How Corleo compares to the rest of the robo herd. Let's be honest, Corleo is not the only robot out there walking on legs, but it is the only one built for humans to ride. Most legged robots today either carry gear, deliver coffee, or perform dance routines that somehow feel more like yoga. Corleo changes the game entirely. It's a clean energy beast of burden with an actual saddle. So how does it compare to the other big names in the robot zoo? Let's start with the one everyone knows, Boston Dynamics Spot. Spot is a 4-legged robot about the size of a large dog. It's electric, fully autonomous, and famously good at walking over rocks, stairs, and uneven ground. But Spot is not designed to carry people. Its maximum payload is around 14 kilos, barely enough for a backpack. It's meant for scanning power, stations, checking pipes, or carrying sensors in dangerous places. You charge it like a laptop, and it runs for about 90 minutes before needing a rest. It's smart, stable, and agile, but more sidekick than steed. Now meet Hyundai's DALI, a robot built for friendly customer service. DALI isn't really a walker at all. It rolls on hidden wheels. It's sleek, talks to visitors, and can recognize faces and gestures. But it lives indoors and struggles with anything beyond showroom tiles. Hyundai designed it to help people, not carry them, and certainly not off-road. It's great at saying hello and posing for selfies, but don't expect it to follow you up a hiking trail. Then there's Yamaha's Motobot, one of the strangest and coolest robotics projects out there. Motobot is a humanoid robot that rides a real Yamaha R1 motorcycle at high speed. It's built to test how much precision a robot can bring to racing. The robot itself doesn't walk. It's bolted onto the bike. It doesn't think like a human, and it can't balance on its own two legs. It's thrilling, but it's more about racing performance than real-world transportation. Now, put those side by side with Corleo. Corleo is designed to carry real humans on real terrain for real missions. It's powered by hydrogen, not gasoline. That means fast refueling, long range, and zero emissions. It walks, not rolls. It has rubber hooves, not wheels. And it has a seat for a passenger, handlebars for control, and sensors that help it walk like a living creature across rocks, dirt, or rubble. And unlike most robots that need a remote control or a pre-programmed route, Corleo responds to the rider's body. Corleo isn't trying to be the fastest, or the most humanoid, or the most social. It's trying to be rideable, clean, and capable. The first robot mount that could one day replace a four-wheeler, not just dance in a showroom. So while Spot trots, Dally greets, and Motobot races, Corleo walks its own path, carrying humans into places no robot has ever taken them before. Before it conquers trails and headlines, Corleo has a few dragons left to slay. What's stopping Corleo? For all its futuristic appeal, Corleo isn't ready to hit the trails just yet. Kawasaki's robot horse might look like a sci-fi marvel, but turning it into a real-world machine won't be easy. Several challenges stand in the way. First, legs are complex. Unlike wheels that simply roll, legs must walk, balance, and constantly adapt. Every time Corleo lifts a hoof, dozens of sensors and motors need to react instantly and in sync. If just one actuator fails, mid-step the whole system could stumble. That level of coordination makes maintenance difficult, especially in remote environments. Then there's the cost. Kawasaki hasn't released a price, but it won't be cheap. A hydrogen-powered, AI-controlled, rideable robot isn't going to be priced like a mountain bike. Until production scales up, Corleo will likely remain a high-end concept, more in the category of luxury tech than everyday transport. Fueling is another issue. Hydrogen refueling stations are still rare in most parts of the world. Unless you live near a pilot project or research hub, topping off the tank would take serious planning. For Corleo to become mainstream, hydrogen infrastructure needs to improve, and that's beyond Kawasaki's control. Legal classification is also a hurdle. Corleo isn't a car, motorcycle, or drone, so where can you ride it? Trails? Roads? Will it need a license? And what happens if it causes an accident? These are the kinds of regulatory questions that will shape whether Corleo becomes a useful tool or stays locked behind policy barriers. Public perception matters too. While many will see it as cutting edge, others may view it as unnecessary, or even unsettling. There will be skeptics who ask, why not just use a regular bike? But that's true of any bold invention. Electric cars were doubted, drones were mocked, smartphones were dismissed. If Corleo can overcome these barriers, win regulatory approval, earn public trust, and become easier to produce and fuel, it could redefine off-road mobility. And maybe one day, we'll wonder why anyone ever doubted a robot horse at all. Corleo's hurdles are real, but so are the crises that demand a beast built for the impossible. Why the world needs a robot horse. Picture a mountain town just after a landslide. The road is blocked by boulders, trees, and debris. Helicopters can't land, wheeled vehicles can't move. Every last minute matters. This is the kind of scenario Kawasaki had in mind when it introduced Corleo at the Osaka Kansai Expo, a vehicle designed to go where wheels can't, and do it without emissions. Why legs? Because they solve terrain problems wheels can't. A quadruped can step over rocks, balance while climbing uneven ground, and lower itself onto soft surfaces without sinking. Tests on other legged robots show they can navigate debris and stairs that stop wheeled and tracked vehicles entirely. But mobility alone isn't enough. Disaster zones and remote areas often lack power or charging infrastructure. That's where hydrogen comes in. A compact fuel cell tank can be refilled quickly and delivers silent, zero-emission electricity for hours. It produces no soot, no carbon dioxide, just water vapor. Hydrogen also aligns with Japan's broader clean energy goals. Kawasaki Heavy Industries already ships liquefied hydrogen across oceans and is testing its use in motorcycles, trains, and ships. Using the same technology in a legged rescue platform brings together clean fuel and all-terrain mobility. The result is a vehicle that can move from paved streets to rubble or forest trails without switching systems or emitting pollutants. Its potential goes beyond emergency response. Rural doctors could reach isolated clinics. Park rangers could patrol delicate ecosystems without building roads. Elderly people in remote villages could regain reliable mobility. Corleo isn't just a robot horse, it's a link between clean energy and real-world access, built for places where traditional vehicles stop. And if you think that's impressive, wait until you see what this tech could unlock tomorrow. How Corleo could change everything. Corleo might be a robot horse today, but what it represents goes way beyond just riding through the woods without a trail. Machines like this could actually shift how we build cities, protect wildlife, and maybe one day even settle other planets. That sounds dramatic, but it's not science fiction. It's where the logic of clean energy and smart robotics naturally leads if you follow it far enough. Let's start here on Earth. Cities today are designed around wheeled vehicles. Wide roads, traffic lights, curbs, and parking spaces are all built for things that roll. But Corleo doesn't roll. It walks. It steps over obstacles, climbs stairs, and balances on narrow paths. Imagine a version of Corleo delivering groceries through a park, helping a disabled person navigate cobbled streets, or carrying gear through a car-free district. Suddenly, cities could start prioritizing people again. More green zones, fewer roads, and walkable neighborhoods where robots blend into the landscape instead of fighting it. Legged machines could help us escape the tyranny of pavement. Now take that, same thinking into the wild. Conservation teams working in rough terrain often rely on noisy ATVs or helicopters, expensive, disruptive, and terrible for the environment they're trying to protect. But a robot like Corleo, it moves quietly. It leaves no tracks. It doesn't spook animals or chew up the ground. Equip it with sensors and AI, and it could patrol for poachers, track endangered species, or even plant seeds in reforestation zones where drones can't reach. In this case, the robot doesn't replace nature. It helps protect it. But here's where things get really interesting. Think Mars. NASA, ESA, and private companies like SpaceX are actively planning a long-term human presence on the red planet. And do you know what every mission needs before humans land? Infrastructure, cargo delivery, habitat setup. And right now, they're testing legged robots for exactly that reason. In fact, the DARPA-backed Team Cerberus recently deployed quadrupeds in Martian-like caves during analog missions. These bots can explore uneven ground that rovers can't touch. They don't need flat roads. They climb. They adapt. A future version of Corleo, powered by hydrogen or solar fuel, could carry tools, build stations, or scout terrain long before any astronaut's boots touch Martian soil. It sounds futuristic, but this is the quiet ripple effect of innovation. A robot horse may start as a mobility experiment, but give it time, and it starts changing the rules. No more needing smooth highways. No more fossil-fueled noise. No more assumptions that transport must mean tires. What we're building is not just a ride. It's a rethink of how we move through the world, and maybe, just maybe, through other worlds too. How Kawasaki got here. Before Kawasaki built a robot horse that could hike over boulders, it built a robot arm that could weld your car with laser precision. And before that, Kawasaki built warships. A lot has changed since the 19th century, but one thing has stayed the same. This company loves building machines that move with purpose. Kawasaki's robot story started in 1968, when it teamed up with an American company called Unimation, the same folks who invented the very first industrial robot. The result? Kawasaki Unimate 2000, Japan's first domestically produced industrial robot. It was hydraulic, clunky by today's standards, and mostly did spot welding on factory floors. But it marked the start of something huge. Japan was serious about automation, and Kawasaki had just thrown its hat into the ring. Fast forward to the 80s, and robots were getting smarter and leaner. Kawasaki launched the P-Series in 1981, its first line of all-electric robots. Unlike the older hydraulic models, these were faster, cleaner, and easier to control. 2 years later came the E-Series, focused on assembly tasks, and by 1989, the J-Series stepped in with more flexible joints that made them better at tricky maneuvers, like handling curved surfaces or squeezing into tight welding spots. The 90s were all about refinement. In 1992, Kawasaki released the UEE series, which brought in better motion control and improved repeatability, essential for industries like electronics, where 1mm errors are 1mm disasters. Then came the FS series in 1998, made for speed and high-precision pick-and-place work. A year later, the Z series joined the lineup, with models optimized for painting and coating jobs, especially useful in automotive factories where an even coat can mean the difference between showroom shine and backlot dull. By the early 2000s, Kawasaki was swinging for the fences. In 2002 alone, it dropped the M series, capable of handling extremely heavy payloads, and the Y series, built for lightning-fast packaging and logistics work. It also expanded into clean-room robotics for semiconductor manufacturing. These robots didn't just work alongside humans. They worked where humans couldn't, like in ultra-sterile chip labs, where a single dust speck can ruin a week's work. But perhaps the biggest leap came in 2015 when Kawasaki unveiled Duaro, a dual-arm collaborative robot. Duaro was designed to mimic human two-handed movements and safely work alongside people without fences or cages. It could do things like box products, tighten small screws, or fold packaging material without taking up much space or accidentally smacking a coworker in the face. It was compact, cautious, and strangely polite. Kawasaki didn't stop there. It moved into medical robotics with the Hinotori surgical robot, designed for minimally invasive procedures like prostate and gastrointestinal surgeries. Created with Seismex Corporation, the Hinotori launched officially in 2020, offering Japanese hospitals a homegrown alternative to the US-made Da Vinci system. With ultra-precise arms and high-def 3D vision, the robot was built to follow a surgeon's exact hand motions in tight, delicate spaces. So when Corleo clomped onto the stage in 2025, it didn't appear from nowhere. Kawasaki has spent over 50 years building robots that weld, paint, pack, and even operate on people. Creating a four-legged machine that walks, balances, and carries humans? That's not a gimmick. That's just the next step in a very long march. But Kawasaki is not just a robotics pioneer. It also builds some of the world's most iconic bikes. Kawasaki's motorcycle legacy. Kawasaki motorcycles are known for one thing above all else: raw, unapologetic power that's somehow always in control. But that reputation didn't happen overnight. After World War II, Kawasaki, a company known for building warships and aircraft, turned its engineering firepower towards something smaller: two wheels. By 1953, they had developed the K1, a modest 148 centiatum 3 four-stroke engine designed to get post-war Japan moving. Just 2 years later, their first full motorcycle, the Meihatsu 125, hit the streets. The company's ambitions grew fast. In 1960, they opened a factory just for motorcycles. By 1961, they had a full nationwide sales network. Then came a game-changing move. They absorbed Meguro Manufacturing, Japan's oldest motorcycle builder. The merger, finalized in 1964, gave Kawasaki access to a lineup of solid four-stroke twins. The result? The W1650 in 1965, Kawasaki's answer to British bikes and proof they could compete on the world stage. Speed soon became Kawasaki's signature. In 1969, they dropped the H1 Mach 3, a two-stroke triple that could blaze through a 1.4 mile. In 13 seconds, it became the fastest production bike in the world, but they weren't done. In 1972, they unleashed the Z1, a 903cc four-stroke that hit 200 km/h and basically invented the term superbike. The 80s saw Kawasaki turn racetrack tech into street muscle. In 1981, they introduced Unitrack single-shock suspension, but it was the 1984 GPZ 900R Ninja that stole the show. The first mass-produced, liquid-cooled, 16-valve inline four-cylinder engine, and the first motorcycle to top 240 km/h. It became an icon thanks to Top Gun, and the Ninja became a global legend. The hits kept coming. 1990 ZX-11 held the world's fastest title for 6 years. The ZX-A6R, launched in 1995, ruled the middleweight class. By 2000, the ZX-12R upped the ante again. Then came the ZX-10R in 2004, the Versys in 2006, and the beastly ZX-14 that same year. In 2015, Kawasaki went nuclear with the Ninja H2R, a supercharged monster that shattered the 300 km/h mark. Technology kept evolving. In 2018, Kawasaki added cornering ABS, brakes that stay stable even while turning. By 2022, they introduced radar cruise control, which automatically keeps a safe distance from the vehicle ahead. And now, electric Ninjas, hydrogen-powered prototypes, and hybrid sport bikes are already in the works. From humble singles to jet-powered beasts, Kawasaki has spent 70 years proving one thing: if it doesn't thrill you, it's not worth building. Kawasaki's bikes set the bar. Can Corleo clear it? In the robot world? Thanks for watching. See you in our next video.